Hello, chemistry students. Today we're going to talk about reaction stoichiometry. So this is a little mole map picture diagram. This is to show you that we always go back to the mole. The mole is the heart of chemistry. So if we start out with atoms, formula units, or molecules, we use Avogadro's number to convert to moles. If we start out with grams, we use molar mass to convert to moles. Or if we start out with volume or liters of a gas, we use volume of an ideal gas, which is 22.4 liters per mole, to convert to moles. And we do the opposite if we're at moles. In order to go to the number of atoms, formula units, or molecules, we'll use Avogadro's number. In order to go to grams or mass of something from moles, we'll use molar mass. And in order to go to the volume of an ideal gas, we will use the volume of an ideal gas constant, which is 22.4 liters per mole. All right, so we have a problem here. It says how many grams of water can be formed by reacting 50 grams of hydrogen with oxygen? The first thing you always do is write down what you know. So we have 50 grams of hydrogen. Now write that underneath the chemical formula or the reaction. So step 1, that is to write down what you know. Step 2, you always write down what it is you're looking for. So we are looking for grams of water that will be produced. So step 1, we are going to convert our grams of hydrogen to moles of hydrogen, and we're going to use molar mass to do that. Step 2, we convert moles of hydrogen to moles of water, and we're going to use a mole ratio to do that, to convert one substance to another substance. And the last step, or step 3, is we're going to convert our moles of water to grams of water by using the molar mass. Now let's follow our map that we have here and write our stoichiometry problem. So we have 50 grams of hydrogen gas. And I know this is a conversion because it says we're going to go to moles. So I'm going to go ahead and draw out my grid. And I know I'm going to moles of hydrogen, so I'm going to write that down because that's what it says I'm going to, moles of hydrogen. Whatever units are in the upper left, we always put in the lower right. And we know this is grams per mole, so we're going to use molar mass. 1 always goes next to the mole if it's not a mole. We find the molar mass of hydrogen by multiplying 2 times the atomic mass of hydrogen, which is 1.01. So 2 times 1.01 is 2.02 grams per mole. Now we are at moles of hydrogen. We need to get to moles of water, so I'm going to add another grid here. And it says I'm going to moles of water next, so I'm going to write moles of water. Whatever units I have on the upper left go to the lower right. So it's going to be moles of hydrogen. Now this is our mole-mole ratio. So we are going to look at our chemical formula to find out what our mole ratio is. We've got moles of water. We look at the coefficient of water, and that's 2 moles of water. Moles of hydrogen, we look at our coefficient of hydrogen, and there's 2 moles of hydrogen. Now I still need to get to grams of water. I'm at moles of water now, so I got to keep going. Add another grid. I'm going to go to grams of water, so I'm going to write those units up at the top. And whatever units I have in the upper left-hand corner go to the lower right. So moles of water. I'm going to use my units to help me determine what numbers to put here. If it's not a mole, and it's not, it's a gram mole, I always put a 1 next to the mole. Grams of water, I find the molar mass to do that. The molar mass, I take 2 times the atomic mass of hydrogen plus 1 times the atomic mass of oxygen. That is 18.02 grams per mole. Now just to check, to make sure, I'm going to cancel my units. I have grams of hydrogen on top and grams of hydrogen on bottom, so they go away. Moles of hydrogen on top and moles of hydrogen on bottom, so they cancel as well. And I've got moles of water on top and moles of water on bottom, so they cancel. I'm left with grams of water. That's what I'm looking for, so I know I set my problem up correctly. So 50 divided by 2.02 times 2 divided by 2 times 18, and the answer to that is 446 grams of water. If we start out with 50 grams of hydrogen, we will make 446 grams of water. Okay, now I'd like for you to pause the video and try this problem on your own. Work it out on your own, and then come back and check your answer. Okay, the answer is 49.5 grams of sodium chloride. If you did not get that answer, then keep the video playing and I will go through an explanation. If you did get that answer, you can go ahead and go to the end of the video because you understand this and you're done. Okay, so it says how many grams of sodium chloride could be formed in a synthesis reaction in which 30 grams of chlorine gas are reacted with excess sodium. So the first thing we're going to do is write down what we know. We know that there are 30 grams of chlorine gas, and we are going to write down what we're looking for. Well, we're looking for the amount of sodium chloride, the amount of grams that can be formed. So we're going to draw our mole map from grams of chlorine. We always have to go to moles of chlorine first, and then from moles of one substance we can transfer to moles of another substance or convert. So we're going to convert to moles of NaCl, and then lastly from moles of NaCl we can convert to grams of NaCl. So this is the map that we are going to follow. Alright, let's go ahead and set it up. So we have 30 grams of chlorine. I'm going to go ahead and draw my conversion, my grid. And I know whatever units I have in the upper left, they always go in the lower right. So grams of chlorine will go there. I know I'm going to moles of chlorine, so I'm going to put moles of chlorine up at the top. If I have mole gram, I always put a 1 next to the mole if it's not a mole. Grams of chlorine I am going to get from the atomic mass of chlorine, which is 2 times 35.45. That is 70.9 grams. Whatever units I have on the upper left, I always put on the lower right. So I'm going to do moles of chlorine. And it says that I need to go to moles of sodium chloride. So I'm going to write moles of NaCl right here. This is not where I want to end, so I'm going to keep going. I have a mole-mole here. This is a mole-mole ratio. I always look at my chemical equation to find that. For NaCl, moles of NaCl, I have 2, so I'm going to put a 2 right here. For moles of chlorine, I have a 1, so I'm going to put a 1 right there. Whatever units I have in my upper left, I always put in my lower right. So moles of NaCl. And I am converting to grams of NaCl, so I'm going to put grams NaCl right here. I'm going to look at my units to help me decide what numbers I put here. I've got grams and moles. I always put a 1 next to the mole if it's not a mole. Grams is molar mass. The molar mass of NaCl is 1 Na plus 1 Cl, and the molar mass of NaCl is 58.44 grams. And if I multiply 30 times 1 divided by 70.9 times 2 divided by 1 times 58.44 divided by 1, I get 49.5 grams of NaCl. And I'm left with grams of NaCl because my moles of NaCl cancel, moles of Cl2 cancel, and my grams of Cl2 cancel. Left with grams of NaCl. Thanks for watching.